Okay, so in this video we'll talk about the floating point types if you need to store a decimal number. Basically, there are two main types, the float and the double. I'll take the float first. The float will allow you to store up to 7 significant digits in decimal number, which is fine for pretty much everything we're going to do in this class. However, I will say that a lot of the C++ library functions prefer the double type, so you will probably find yourself using that a lot too. Even if you don't need as much as 16 significant digits, which that type can accommodate. So, but anyway, getting back to the float, here's a float variable which I've called price, and we'll use it to store the price of a book. This is interesting. I'm going to hover over this and look at this little sign popping up showing us the value in this variable. It's a floating point types. Floating point numbers are stored as approximations in memory. I'm thinking it's 995, but it's actually this number. It's not quite 995. So some more terminology here as well. That we know that this is a variable. It's a variable name. And the number that I'm putting into the variable, this hard-coded number, this 995, is called a constant or a literal. It's just a number that you've hard-coded into your program. It's a literal. And, you know, these are string constants or string literals. It's literally that. It's not a variable. So now that you know what a variable is, you know what a literal is. A literal is a value that's hard-coded into your program. Another thing is I'm going to build this solution. When you build a solution, oh, actually, I'm already running this. Let me get back to normal here. I'm going to build the solution. You can build a solution. You're basically just compiling the program without running it. And I did that to, I thought I was going to get a warning on that 995. Sometimes you'll get a warning if you try to put this constant here, this 995, it's actually when you type in a decimal, into hard-coded decimal into your code, the compiler just automatically thinks that's a double, even though we intend it to be a float. You can see here the compiler saying, oh, that's a double. She typed a decimal into her code. It's a double. So if you want to take control of your constant, say, no, this is a float. I want to put that into a float variable. You can put an F after it. You'll see that from time to time in code. You're just saying, okay, this now you can see it's a float type constant as opposed to the default, which would have been double. So in any case, we'll go ahead and run this. And just to show you a couple of things about decimal precision. So here we see the price of the book is $9.95. That looks good. And then in the next line, I did a quick sale calculation. Like, let's say the book was 10% off, so I'm saying the price is 90% of itself. So I just plopped the math operation right into the output stream, right into the cout statement. But look at my result. It doesn't look like money. I will show you how to set the decimal precision in your output in a later video. I'm not going to bother with it here, but that is coming very quickly. All right, and then we have the double type, and here I have a double which I've called pi, and I'm putting a long number pi into it. This is the larger of the floating point types, and it can accommodate up to 16 significant digits. And so, yeah, but if you notice, the program is running here, this is the number in memory. Well, it's not quite what I typed. You can see there's a lot more precision there than what I have hard-coded into my code. Again, these floating point types are stored as approximations in memory. It's not actually the number that you have typed. And, you know, for the most part, it's not going to be too huge of an issue. Every now and then that'll come back to rear its head, and you know, we'll have to be mindful of that. But for the most part, you don't have to worry about that too much. But in any case, notice the precision I'm getting on the output of my pi number is not quite what I wanted. Again, I will show you how to manipulate decimal precision in a later video. One more quick thing. Typically, when you have a number like this, like pi is this number, and we should not ever have that change. Like that number is pi is pi. It's always that number. It's never you would not want your program or somebody to turn around and be able to say pi equals 1. Okay, and look, the program is letting me do it. If you want to lock down the value of a variable, you can use the const qualifier. And this is used quite a lot in your book and in programming in general. It's like you're just like locking down that value. You're making the variable value constant, meaning it cannot be changed. And so that would make sense in this situation because we would not want this number ever to change because that is the value of pi. So, okay, in the next video, we'll talk about some of the other miscellaneous data types.